This is video 3 of 3, starting in the middle of page 10, going to the end of the chapter 2 class notes on page 13. Here, we will begin talking about cost behavior. Specifically, you need to be able to define four basic types of cost behaviors: fixed, variable, semi-variable, or aka mixed, and step cost, or otherwise known as semi-fixed cost. So know those four basic types of cost behaviors, understand how they're represented in graphs or in depictions such as these. Let's define them and provide examples for a car manufacturer. So the first one is a cost that does not change with volume. It remains fixed or flat. It does not change when, say, the number of cars produced changes. So that is a fixed cost. Basically, it doesn't matter how many I produce. If I produce none, if I produce 10, my costs remain the same, flat across the board. So for a car manufacturer, that might be something like factory rent. Say they rent their building at $5,000 a month. It doesn't matter if I make one car, or if I make 10 cars, or 1,000 cars. My factory rent is $5,000 per month. A feature of a lot of fixed costs is that they're flat over time. They're not a function of, the number of cars you make or number of cars you sell or anything like that. They're a function of just time. They do not flex with volume. Then a cost that changes proportionally with changes in activity volume, or changes in units produced or sold in this case. If it changes, that is to say that it varies. It is a variable cost. Vary is another word for change. So for a car manufacturer, think about something like the engines that are put in the cars. Every single car I make requires an engine. And say those engines are $6,000 a piece. Each additional car I make adds $6,000 more to my total variable cost. Direct materials are pretty frequently a variable cost, or almost always a variable cost. Direct labor can be a variable cost. It depends on the nature of that labor. But a good deal of production line labor is a variable cost. Things like shipping costs can be variable, sales commissions, typically variable. They change with activity. Then I've got some kind of cost that is both variable. It has both variable and fixed elements. This is a mixed cost. It has both, or I'm sorry, your textbook likes to call it a semi-variable cost. So it's got both. It's got a fixed element. So over here is how it would be graphically depicted. Basically, even at no units, if I produce nothing, I still have some flat rate. It's above zero, so it would still cost something, even at 0 units. But it does steadily increase with the more units that I produce. It's got a fixed element here. That steady slope upwards is a variable element. Note that it looks a lot like the variable cost graph over here, the difference being where they originate. This truly variable cost is represented by its origin at 0. So at 0 units made, I also have $0 in cost. There is no fixed element to that. A common example of semi-variable or mixed cost would be like utility bills. So take water. Let's say that the water bill looks like something like it's $10 per month flat. Doesn't matter if you use 0 gallons of water, you're paying that $10. And then 5 cents for every gallon that you use. That flat $10 a month is fixed. That charge per gallon used is variable. And lastly, we have step cost or semi-fixed cost. They change in steps. It literally looks like a series of steps at some flat rate increment. So say that this is $200 at every 10 units. If I make 10 units, $200. I make 10 units more, or 20 units total. I'm at 400. I make 10 units more at 30 units. I'm at 600, so on and so forth. It increases in these at a flat rate for every so many units or for every so many units of volume. So say something like an inspector's salary. Say every 100 cars that I produce, I have to have another inspector on staff. So for every 100 cars, I'm paying a salary of $800 to an inspector. Need one inspector for every 100 cars. So at 100 cars, it costs 800. It's $800 up until the point I hit 200 cars. At 200 cars, it's 1600. 300 cars, 2400. Constantly increasing at a rate of $800 at every time I hit a 100 unit threshold. You want to consider these cost behaviors when you're predicting cost, especially when considering like short-term opportunities in the future, like whether or not to accept a special order in a period. You're unlikely to be able to avoid those fixed costs. They're not really relevant, but you would want to consider any cost with a variable or with a changing element. Step costs, like give you these thresholds. You want to look above and below the thresholds for those orders. You want to consider cost behavior, knowing that you can kind of ignore fixed costs that are unlikely to change, but projecting what will happen with regards to your variable, semi-variable, and step costs. Um, Note that cost classification or cost behavior classification can be difficult for a number of reasons. There's 5 factors your textbook provides. I should have said 1. Sorry about that. Um, First off, it's not just a simple classification as variable or fixed. Costs like semi-variable or mixed costs can actually be both. They're not mutually exclusive. So sometimes you see a singular cost that has distinct variable and fixed elements. Then some costs change in steps rather than at steady rates. So these here, sorry, got distracted. So it's not really variable, but it's also not really fixed in place. It's like a odd fixed on a variable schedule kind of cost. Cost relations are only valid within a relevant range. So at some point, you might see a change in your variable cost per unit. Typically, that's steady. That's the reason why the slope is steady. But there might be some point where if you buy so many units, you get like a volume discount. So it decreases, which kind of disrupts things or introduces noise. There can also be a point where there's a change in total fixed costs above a certain level, more or less like kind of that's pretty similar to the step costs, except for kind of assuming that that relevant range is much broader in this case than it is with the traditional step cost. But sometimes beyond certain thresholds, you see disruptions in the cost relations. This, I don't know how these got shifted. That was supposed to be 4. and that 5. Um, there can also be random noise or distortion in the data, which makes it difficult to classify them in the real world. Um, sometimes, like, there are just shifts in the price for other reasons other than cost behavior, um, or just weird little things that happen that cause your data to be a little murky or for it not to hold true all the time. And then when it's aggregated, it all just kind of gets buried deep in the data where there can be some error or noise in your data. It's not always super clear cut across the board. Um, Classification can also depend on activity measures. So we typically think about activity measures or volume measures in units. Units produced or sold is a really, really common one, particularly for manufacturers. But it could you could use other activity measures. Um, and it's possible that the cost behavior would be dependent upon what that activity measure or volume measure is. It could be that a cost is defined as variable if you're looking at it or measuring it in one activity, or it could be a fixed cost or a stepped cost if you look at it for another activity or volume measure. So, for example, like an example of that particular problem, think about like these engineering costs or setup costs relating to calibrating machines for each production run. So, every time they're ready to do a production run, it requires all this work to get the machine set up and calibrated. It costs $12,000 for each production run, and every production run produces 4,000 units. How I classified the behavior of that $12,000 setup cost depends on the activity measure. So, if I use production runs as the activity measure, I'm defining it with its relation to production runs. It's $12,000 per production run. Thus, it's variable. It varies proportionally with every single production run. Every single production run, it increases 12,000. It changes at a steady rate. If I define it with relation to product units, though, $12,000 for every 4,000 product units. Each production run, so it's 12,000 per production run. Each one produces 4,000 units. It would look like a step cost with it increasing by $12,000 for every 4,000 units. Okay. So let's do some calculations that factor in cost behaviors. So how costs are assigned to products depends on the costing methods that managers are employing, either variable or absorption. Method absorption is what is used for financial accounting purposes, whereas variable is not GAAP. And because it's not GAAP, it can only be applied for cost accounting purposes. You cannot report that as the primary basis, like your income statements, um, for financial accounting. Absorption costing incorporates all product costs and treats all product costs like product costs. Direct material, direct labor, overhead, all of those product costs are absorbed and treated, or absorbed as product costs. If it's a product cost, it's treated like a product cost. So direct material, direct labor, overhead. That includes both fixed and variable overhead. FOH means fixed overhead, VOH, variable overhead. All of them are assigned to product units, or all of them are classified in inventory cost. Under variable costing, it includes only the variable product cost. It specifies product cost, so it is specifically talking about the variable elements of direct material, direct labor, and overhead. Nothing beyond that. Variable SG&A would not fall under variable product cost because SG&A is not a product cost, it's a period cost. But it includes only variable product costs in the product cost. So essentially, fixed overhead is treated as a period cost, treated as a product cost under absorption, treated as a period cost under variable. So that is the distinction between the two. The only difference between them is how they treat fixed overhead. Absorption treats it like a product cost. Variable treats it like a period cost. So here we have the following info for gold manufacturing. And we're asked to use this info and compute a few things. The first is fixed overhead per unit. So this is per unit produced. My total fixed overhead cost $12,000 divided by 2,000. I'm going to spread it out over the 2,000 units I produced. 12,000 divided by 2,000. $6 per unit. Fixed SG&A per unit. That's a total of 14,000. Allocated out over the 2,000 units. $7 per unit. Next, we're going to calculate product costs per unit. Remember, product costs comprise of direct material, direct labor, overhead in some form. If I'm using absorption costing, it absorbs all product costs. Variable includes only variable product costs. So, for absorption, I would include these that I'm starring are product costs, direct materials, direct labor, some type of overhead in general. Those would be defined as product costs in general, or more broadly. Absorption and variable costing, though, implements their own rules over these. Absorption does treat all these product costs like product costs, so it would treat that $5 $8 for direct labor, variable overhead of $3 per unit, fixed overhead, need that also in per unit terms, $6 per unit. 5 plus 8 plus 3 plus 6. $22 per unit for absorption. For variable, I include these three, but not fixed overhead, that's $6. That is $16 per unit. Next, we're going to calculate variable cost per unit. Note that doesn't say variable product cost, it just says variable cost. And we'll see overall variable cost per unit, not just the product, the variable product cost. So all the variable cost, we're assuming direct material and direct labor are variable. Direct material almost always is. Can't really think in my mind, think of an instance where direct material wouldn't be variable. And particularly for manufacturers, a good deal of direct labor is safely assumed to be variable. So all three of those would be variable. Obviously, the variable SG&A would be variable. These two are fixed, so they don't apply. Basically, these costs here are the ones that are variable. The 5, 8, and 3 that were part of the variable product cost, plus also variable SG&A, which was $4 per unit. All those are in per unit terms. Five plus 8 plus 3 plus 4, $20 per unit. Lastly, I want to calculate the full cost per unit. Not just product cost, we're just wanting the complete cost per unit. So all of these, obviously sales is not a cost, we're going to exclude that. But the 5, 8, 3, fixed overhead of 6, plus variable SG&A of 4, and the fixed SG&A of 7. So all the product costs and both elements of the period cost. Add those up. $33 per unit. Let's say I want to do income statements under the absorption and then under the variable methods. Note that the absorption costing income statement is more or less just the traditional gross margin type statement we've done already. Variable breaks cost out into variable and fixed elements and does something called a contribution margin income statement. So same info from the prior page. Say that that was the number of units produced and sold. Remember, this was calculated at being $6 per unit. This was calculated as $7 per unit. Absorption product cost on the prior page had been that 22. For the variable product cost, it had been that 16. Okay, let's do our income statement under the absorption method. Remember, all income statements are essentially capturing the net income equation, which is revenue minus expenses. So I'm starting with the revenue. The only revenue account I've got is sales at $40 per unit. So I sold 2,000 units at $40 each. 2,000 times 40 would be $80,000. Then this traditional absorption statement, or gross margin statement, I'm trying to calculate that here. I need cost of goods sold to get gross margin. It's about what's left over after factoring in the cost of the inventory I've sold. So, to get cost of goods sold under an absorption statement, I need the absorption product cost per unit. That's the cost I assigned to the product. So $22 times the number of them that I sold, which was 2,000. 2,000 sold, costing $22 each. 44,000 in cost of goods sold. 80,000 in sales minus the 44,000 that the inventory had cost of goods sold, gives me a gross margin of 36,000. Then I've taken care of cost of goods sold. I need to deduct the rest of my expenses. So I need to remove SG&A. Note I'm not classifying it as variable or fixed. It just says SG&A, which means that I want both variable and fixed SG&A all locked in together. So total fixed SG&A had been 14,000. Variable SG&A was $4 per unit times, this is selling cost, so times the number of units that I sold. 4 times 2, 8,000 in variable. 8,000 plus 14,000. That is a total of 22,000 in total SG&A. So take the 36 I had in income left over after taking cost of goods sold on, after reducing by that expense, and go ahead and subtract out the rest of the expenses, the SG&A of 22. That leaves me with operating profit of $14,000. Note, given that units produced and sold are the same number, I expect this to also equal 14,000 if I've done it correctly. So variable costing, once again, it's an income statement, which means we're looking at some revenues minus expenses. That's always going to be the essence of an income statement. That's the essence of income itself. So we start with the one revenue I have, which is still sales. I still sold 2,000 of them, still at $40 a piece, so sales should still be $80,000. Now, I'm doing the contribution margin statement, which means I want to calculate contribution margin first, which requires me to split my expenses or costs in between variable and fixed. Since my first income measure that I intend to calculate is going to be contribution margin, remember that contribution margin is always sales minus variable cost. I want to first reduce sales by variable costs. Variable costs will be my first focus here. So, I want my variable cost of goods sold. I also want the variable elements of SG&A. So I use my variable product cost, which was $16 per unit, and multiply by the 2,000 units that I sold. So I sold 2,000 of them. I said each of them were worth $16 a piece. Gives me variable cost of goods sold of 32,000. Then I need my variable SG&A. Once again, I sold 2,000 of them. Variable SG&A is at $4 per unit, 8,000. Note, that's the same as it was up here. We're just going to split out the SG&A costs in their variable and fixed elements on this version of the statement, but the underlying costs are still the same. I've still got 8,000 in variable. I'll still have 14,000 in fixed SG&A. It's just split out differently. That is both of my types of variable costs. So I'm ready to calculate contribution margin. 80 minus both of the variable expenses leaves me with 40,000 in contribution margin. Now the only other type of expenses I have are the fixed costs. So I have fixed overhead, fixed SG&A. These are simple. We treat fixed overhead like it's a period cost, which means you just bring the entire 12,000 down. It's all expensed as it's incurred. Doesn't ever filter through inventory, so just expense it as given. All of its period costs. Fixed SG&A, 14,000. So 40,000. That's left after deducting variable costs. Minus 12 for fixed overhead. Minus 14 for fixed SG&A. Leaves me with $14,000 in operating profit here too. These are the same. Note those numbers would have been different if the number of units produced and sold had varied, if a different number was produced than was sold. With those differences coming into play because of differences in how they treat fixed overhead. If it's product costs, that means it gets expensed when the units are sold. If it's a period cost, like it is in variable, it just gets expensed immediately. So it causes differences in how much is expensed. specifically for fixed overhead. Okay. Lastly, how can we make cost information more useful for managers? We just talked about how to do those particular income statements and use those particular costing methods, absorption and variable, that is, how to use those different income statement formats. That's not the only options, though, that we have. So while absorption is basically used in financial, it has to be used in financial reporting. It is GAAP. Variable costing and net contribution margin income statement are not GAAP. It is primarily used for internal or managerial or cost accounting purposes. And it can be quite helpful because of how it groups the costs by their cost behavior. So it gives you an idea of what profitability looks like without the fixed costs, which typically can't really be changed in the short term. So if you were looking at assessing this just short term offer that's in the very near future, it gives you a better idea of the profitability without considering costs you cannot change, like fixed costs. However, that's not the only option you have. Managers can really use any kind of costing method that makes sense for the problem they're trying to address. And they can put it in any kind of format that makes sense for the problem they're trying to address. It's very flexible. The goal here is for the information to be relevant to their decisions, so they can put the information in a way that helps it do that. One of the ways that the textbook kind of provides as an example would be income statements that split up cost in columns, classifying them into costs that stem from non-value added activities and costs that stem from value added activities. That helps them identify potential things that they could eliminate and what the impact of eliminating those non-value added activities could be on their profitability.